but check this out. quantummagazine.org. We're going to start here. Check this out. This is the cue the cosmic whales. You're totally right, dude. What's up? The Night Stalker is here. Check this out. This is from Quantum Magazine. How the physics of nothing underlies everything. The key to understanding the origin and fate of the universe may be a more complete understanding of the vacuum. All right, here we go. This is millennia ago. Aristotle asserted that nature abhors a vacuum, reasoning that objects would fly through truly empty space at impossible speeds. In 1277, the French bishop Etienne Tempier shot back, declaring that God could do anything, even create a vacuum. All right. Then a mere scientist pulled it off. Otto van Guericke invented a pump to suck the air from within a hollow copper sphere, establishing perhaps the first high-quality vacuum on Earth. In a theatrical demonstration in 1654, he showed that not even two teams of horses straining to rip apart the grapefruit-sized ball could overcome the suction of nothing. All right, we're talking about nothing, the vacuum, right? The nothing. Here we go. Let's just read more of this. This will say it better than I ever could. Since then, the vacuum has become a bedrock concept in physics, the foundation of any theory of something. Von Guericke's vacuum was an absence of air. The electromagnetic vacuum is the absence of a medium that can slow down light. And a gravitational vacuum lacks any matter or energy capable of bending space. In each case, the specific variety of nothing depends on what sort of something physicists intend to describe. Quote, "Sometimes it's the way we define a theory," said Patrick Draper, a theoretical physicist at the University of Illinois. And, well, yes, indeed. Let's go down here. Quote, "We're learning there's a lot more to learn about nothing than we thought," said Isabel Garcia? Double Garcias, a particle physicist at the Kavli Institute for Theoretical Physics in California. "How much more are we missing?" she said. All right. Now this is wild. So far, such studies have led to a dramatic conclusion. Our universe may sit on a platform of shoddy construction, a metastable vacuum that is doomed, in the distant future, to transform into another sort of nothing, destroying everything in the process. And we've talked about this in the past, right? This idea, the big crunch, and and again, as Matt in California was saying, Matt in Colorado, sorry about that, was saying yesterday, he was talking about how the James Webb Telescope has sort of punched a hole in the theory of the Big Bang itself. Meaning, we're going to have to start looking for different cosmological definitions and ideas of where the universe actually came from. And so, there's a lot to think about, okay? So back to the idea of a vacuum and back to the idea of nothing. What exactly is nothing? Is it possible to have nothing? Again, I was kind of going through some ideas here of thinking as not just space in the vacuum we know as something, but what could it be? And some of the theories in the past have been space as an ocean, okay, which we're going to talk about tonight. And so I got some wild theories for you because, hey, this is Troubled Minds. If we don't do it here, like I always say, who's going to do it? We're going to do it. Oops, that's bad. Don't drop that mic. So that's what's going on. Okay, so I got some questions for you, which I'm going to ask in just a sec. But I want to get back to this. So this got me thinking in terms of the vacuum, the vacuum itself, meaning nothing. All right. But, we're learning that even in the absence of something, it doesn't mean there's nothing. It means that there's still a quantum something happening. And so what does that mean in a vacuum? If there's quantum something that appears as nothing, it's called quantum nothingness. Yeah, that's right. That's a real thing. Let's go here. Quantum nothingness, straight back to this paper. Nothing started to seem like something in the 20th century as physicists came to view reality as a collection of fields, objects that fill space with a value at each point. The electric field, for instance, tells you how much force an electron will feel in different places. In classical physics, a field's value can be zero everywhere, so that it has no influence and contains no energy. Classically, the vacuum is boring, said Daniel Harlow, a theoretical physicist at the Massachusetts Institute of Technology. Nothing is happening. All right? Okay. However, physicists learned that the universe's fields are quantum, not classical, which means they are inherently uncertain. Which means, of course, the space that we know as space and the vacuum as we describe it may indeed be something other than nothing.